Problem number 11. Integrate this function here over the region with these bounds by converting to polar coordinates. Okay, let's start thinking about the bounds for this region in polar coordinates. X squared plus y squared is less than or equal to 1. That's r squared is less than or equal to 1, or r is less than or equal to 1. We're going to have the region that is inside a circle of radius 1, centered at the origin, so that's one part of it. This part over here, x plus y is at least 1. X is, we should know, r cosine theta. Y is r sine theta. And so let me write that as an equals here to come up with an equation. It's going to turn out to be a line here. Well, we can tell it's a line. X plus y is equal to 1. Solving for r in terms of theta, r times cosine theta plus sine theta is equal to 1. Divide both sides by cosine theta plus sine theta. And so here is the equation of our line. Of course, we know just from plotting x plus y is equal to 1. We know that's the equation of x plus y is equal to 1 right there. And we want x plus y to be greater than or equal to 1. So the region in question is this little moon-shaped region right there. Okay, so, and this line now has polar equation r is 1 over cosine theta plus sine theta. Okay, we need bounds on theta, and we need bounds on r. Theta can be anything from 0 to pi over 2. R can be anything from, the biggest r can be, is when we hit this out here, r is equal to 1. The smallest r can be is right here, when we hit r is equal to 1 over cosine theta plus sine theta. And so this right here, this gives us all the bounds that we need. So we are integrating. Theta is running from 0 to pi over 2. R is running from 1 over cosine theta plus sine theta to 1. Now what about the integrand here? Integrand is going to be, we replace x squared plus y squared. We replace this with r squared. R squared to the negative 3/2 is r to the negative 3rd power. So r to the negative 3rd power. And then we need to throw in, don't forget to throw in the r dr d theta. And so theta runs from 0 to pi over 2. R runs from 1 over cosine theta plus sine theta to 1. This is r to the negative 2nd power dr d theta. Okay, so we need to integrate this a couple times. First, antiderivative r to the negative 2nd power will be r to the negative 1st power. So, negative r to the negative 1st power. Plug in r is 1 over cosine theta plus sine theta and 1. Okay, plugging in 1 gives us negative 1. Plug in 1 over cosine theta plus sine theta. 1 over this to the negative 1st power will just be plus cosine theta plus sine theta here. Okay, now we just need to integrate this with respect to theta. Negative theta, let's see, plus sine theta minus cosine theta. Plug in from 0 to pi over 2. We end up with negative pi over 2 plus sine of pi over 2 is 1 minus cosine of pi over 2 is 0 minus 0 plus 0 minus 1. And we end up with 1 plus 1 is 2 minus pi over 2. Okay, concluding thoughts here. I guess the most important thing here, number one, draw the picture. You don't draw the picture, it's going to make your life a lot more miserable. Figuring out what bounds on theta are, stuff like that. Figuring out what bounds on r are. Number two, to figure out like the bound here, just make sure you substitute in x is r cosine theta, y is r sine theta, solve for r in terms of theta.